So we have a highly high-ranking panel today. This afternoon, Professor Serpanos has joined us. He is an electrical and computer engineer. He's working at the Institute of Industrial Systems in Greece. Has a PhD from Princeton University, has been working with IBM Research, University of Crete, University of Patras, and is working with University of West Greece, and is very active at IEEE. And he's a specialist in embedded systems and also security. And I would like to request you give you a short intro statement.
Thank you. Thank you. Can okay. I assume I can. That's okay. 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 Thank you very much, and thank you for staying back from a long day. So I just want to. I'm not going to take a lot of your time. Just as my position statement was requested, I just want to lay some ground. Make sure that you know we are in, let's say, on the same page. So, in regard to the security of industrial control systems, specifically like you know like smart grid control systems and so on, we have been working on you know various systems, and in general, for every operational system, I guess what is the simplest thing one can say is that the approach to build them and to operate them is to build them right and monitor them continuously. This is, I think, what we have been hearing for the last couple of days in one way or another. Of course, this is more of a political statement rather than a precise engineering directive. So it needs a little bit more qualification. And the only reason that I bring it up is because it directly indicates to things that we have been discussing for more than a decade, let's say, especially for security, which is to design systems from the beginning so that they are secure and reliable by design. This is something that, especially in industrial control systems, relates not only to the hardware and the software that's involved, but also to the processes themselves. And one of the issues that I want to raise, I'll bring in the next slide, is that probably processes have not been addressed sufficiently. Of course, in order to design systems, we need to have models for the attacks so that we can make them secure. And here, of course, we need to know you know, what has happened in the past, but we should be prepared also for the future, which is unpredictable. In terms of monitoring, basically we are talking about software in our systems, at least in the view that I'm looking at right now. And for this, we have to be able to detect failures and attacks. But one of the issues that has not been raised, I guess, enough is that we have to go also through diagnosis and recovery. Certification, auditing, and testing are, of course, related issues. And although, as I mentioned, the last 2 days we have been hearing about, you know, several of these aspects, the question that I would like to raise is whether we really know how to do all these things, you know, the secure and reliable design, as well as the appropriate monitoring. And the reason is, you know, that there are several technical challenges, in my view, that have not been addressed sufficiently yet, at least. And they have to do, for example, with you know, secure design from scratch, because we do not really know how to design systems with very strict security properties. You know, political statements like the one I mentioned before, like build it right, do not really mean much, because right is a very abstract word. The question is, what kind of properties do we want our systems to satisfy? I'm not even sure, and believe me, I have been working on hardware systems for a very long time. I'm not sure that you know, many designs exist that use TPMs, trusted platform modules, appropriately, or to the degree that they can provide specific guarantees for security. I believe that it's time to discuss system verification and validation, which brings the processes into the picture a lot, because we don't really know many times exactly what our systems are doing or whether they meet the requirements of the processes for which they were built. I mean, do they really do the job that they are intended to do? And if yes, how? Also, in regard to monitoring, I think that one of the major issues that is coming up these days is these false data injection attacks. We heard some talks the last couple of days, but in my view, even the 2-3 talks we heard are not enough to address this very serious problem. Of course, we still have the computational attacks, you know, viruses, worms, and all these intrusions. And in my view, and if there is a question, I will be happy to discuss. I believe that all these approaches are very relevant to certification, which is necessary for operation in the field. Can we take lessons from other, activities? I think yes, we can. I used here the term planes, trains, and automobiles. It's one of my favorite movies for those of you who are interested in movies. But the reason I mention it is because I believe that the technologies that have been developed in aeronautics, automotive industry, and so on, because of their immediate liability for passenger safety, have made some extra progress, especially in the use of formal methods to prove specific safety properties for the systems. And I believe that this is a direction we can go also for smart grids and all other processes like this. Thank you.
Thank you very much. So our second panelist is Professor Ruland from the University of Siegen in Germany. So Professor Ruland has studied mathematics, physics, and computer science at the University of Bonn, has been working as a professor at the University of Applied Sciences in Aachen, and is now, as I said, in Siegen. And he's a specialist in cryptography in industrial communication systems. So I would like to also request you to give your intro statement. There is another microphone.
Okay.
Thank you.
Yeah. Thank you, and good afternoon, ladies and gentlemen. I titled my statement, Cyber-Physical Security is different. Okay, what does it mean, and different from what? Okay, difference in communication compared to non-cyber-physical systems. In non-cyber-physical systems, we have information exchange, file transfer, email, videos, banking, software download, internet services, and so on and so on. The attacks are by eavesdropping, masquerade, authentication, denial of service, data manipulation. Okay, what are the risks? For example, viruses, loss of data, money, privacy, trustworthiness. Okay, what is the situation with cyber-physical systems? It is not information exchange directly. The goal is remote control of physical devices, of plants, comparable to fly-by-wire. We have direct access and direct control to physical devices, to processes, and that is the difference. Okay, the attacks are the same as before, but additional also misuse of rights. And okay, what is the result? Okay, unrecognized, unauthorized control of cyber-physical systems, also by insiders. Okay, so who are the attackers? Okay, and then, of course, at the end, the risk is a blackout. Difference in security. Communication security is not enough. Always we focus on communication security. It is not enough. Why? The application protocol data units are protected uniformly without respect of the context and impact. The APDUs and the protocols, they don't know what they transport, what is inside, what is really the meaning, what is the risk of the transported commands. And the problem is the applications are not on the same level. The applications themselves perform multi-critical commands on physical devices. Some commands are harmless. Some commands are very critical for security and safety. And this cannot be recognized from outside, from the protocol, okay, what level of security is needed by this specific command. Okay, so security must focus on the individual content of the APDUs. That means, okay, the device control commands, the parameters, and even each parameter value have to be checked. What is the impact? Who is allowed to set it? Okay, and so it's beyond communication security. What does it mean is we need a change of paradigm. We don't need a top-down security, but bottom-up. What does it mean? Top-down, I think, okay, we come from communication. We have IPsec, we have TLS, DTLS, 62351 security protocols come lower and lower, maybe all to security for MMS protocols, but then it's finished. It is not possible to look inside of the data. But what do we want to protect? We want to protect the transactions, the commands. So we have to start with the protection of the commands. That's what I mean. Okay, we have to start, when you see the data model, the tree, we have to start with the security of the leaves. What is inside? Yeah? And so, okay, we need a very granular security requirements for each single parameter of command and also for the responses. Okay, so I think the actual approach of smart grid security has to be extended. That is not, it is necessary but not sufficient. Okay, and also especially under the aspects that maybe also the type of the attacker is different. He has more and more insider knowledge, and maybe he can also be the insider. Okay, thank you.
Thank you very much, Professor Ruland. And our third panelist today is Dr. Paschalidis. He is an electrical engineer, has been studying at RWTH in Aachen in Germany and TU Braunschweig, where he got his PhD from. He has been working with Fraunhofer, and now he's with the company P3, that is, for example, doing Tetra security, and he's in the field of critical communications in critical infrastructure, basically.
Okay. Thank you very much.
So please also, can I request you for your short statement?
Hello, everybody. So I think this is the last one. It's only one slide. So what I want to say here, maybe as a fire starter, one concept in smart grid does not fit all. So top-down and bottom-up approaches are actually projections of centralized or decentralized architectures. And centralized, you are more in the traditional critical infrastructures where you have one unit, let's say, controlling everything. And then decentralized, you are more in the market or the free agent architectures. So far, the grid was completely central organized with one direction, and it's now transforming towards decentralized customer-centric energy architectures with high amount of renewable energy, causing destabilization, and it changes the points of interest and as well as the information flow and the energy gradient. So it's not only you're not only a consumer anymore, but you can also be potentially a producer. So the applied security concepts are being transformed accordingly, but all these let's say concepts are going towards a very, very highly decentralized architecture. So I want to, let's say, be a bit more challenging here and say that it's highly unlikely that the resulting architectures will be completely free from hierarchy or layered control levels. So both in the foreseeable future, both architectural concepts, so centralization, top-down, and decentralized concepts will be in place to a balance point which has still not converged. The new players that are coming in the field also are trying to find, let's say, their position. So towards ensuring secure systems, we need security integrated both on the top-down, on a bottom-up, so to say, on an element basis, but also on top-down high-level control mechanisms that can overview and step in when critical situations arise. So for me, it's also, let's say, a difference between analyzing a problem and synthesizing a problem from its elements. So you need, of course, element level security, open designs and systems, and integration in the design phase. But you also need, from the top perspective, you need standardization and standardized processes and certification, as was mentioned. You also need overarching incident management for critical incidents and also coordination between the different actors at a very high level. So this is also what was said, some steps that are being done with the NIS and aggregation processes where data can be, let's say, aggregated and processed at a very high level to extract this information. So this is, let's say, my slide on that. Thank you.
Thank you very much. Please join us. Right, so the main idea is to discuss where to go from here now, what are our reflections on the symposium, and maybe as an organizer I can say I hope we had done some community building effort with this event. I've had the pleasure to witness this kind of community building in different other fields like smart grids, which is now power system digitalization, smart cities and others. And I have the certain feeling that although the security field is being worked on already quite a few years, we have to do the same here. And the question is, where is the field and which are the main points to go from here? So we have seen in the previous days, there are, let's say, there's a very large difference of the flying level we are in. So we have problems of just missing end-to-end encryption, which is not really a research topic, it's just you have to implement it. But we have also on different levels really automatic attack vector detections and other approaches. And so where should we lie the focus? So that would be my first question. Who is daring to reflect on that?
May I? So I agree completely with my experience that the truth outside, in the field is very, let's say, at some points a bit, let's say, disheartening, because we know there are many, let's say, DSOs and operators that lack very, very basic security measures. So this is something that should be, let's say, implemented, let's say, right away, so to say yesterday already. This is where the focus in the industry should be, to, let's say, make more to bring it more into attention. What are the potential risks? Because the more penetration you have from smart systems, the more risks you have. On the other hand, of course, this doesn't mean that we have to, let's say, stop research and looking for new solutions, because we know there are problems. And all run behind, let's say, the operators. This is, of course, the truth. In the research, what I saw, for example, here in the symposium, and what I think is very interesting, I think there's a lot of that needs to be done still, is in IDS systems that incorporate, let's say, the domain knowledge, so that the results are not, let's say, that there is more than a very, very simple plausibility, but also more intelligence into these idea systems. So,
thank you.
Yeah.
Okay. Let me also give an additional view. So in my view, cybersecurity, not only in power grids, but everywhere, is like a process which is continuous, and it's like a loop in some sense.
Endless loop, unfortunately.
Yes. So the point is that, in my view, at least in most of the organizations, it's necessary to go repeatedly through this loop of identifying weaknesses, fixing them, and reevaluating all the time. Because sometimes, even with solutions that you introduce, you create some new risks that have to be reevaluated, and so on and so forth. So in that respect, basically all problems will need to be addressed sooner or later. It's a matter of prioritization, risk assessment, and you know, how every operator or how every stakeholder gets involved into this process. But definitely everything has to be addressed, and every organization should be doing it, you know, in its own way. However, I think that this is also a point where some type of certification or authorization, if you will, is necessary. For example, in the military space, companies are being ranked according to the security provisions that they implement themselves for their processes, so that, for example, designs don't leak, you know, who has accesses to specific products and processes and so on. Something similar can happen and should happen also in critical infrastructure organizations and operators, so that everybody knows the level where they are and where they should be in order to participate with specific roles.
Mm-hmm. Thank you.
Okay. I would like to draw the attention to another construction site, that is a transmission system itself. Because smart grids, they are a multi-critical system, and we don't have not only SCADA information, we have also commercial information, we have banking information, we have information to the outside. And some of them are critical, real-time critical, and the other not. And the problem is, okay, how is it possible that maybe the application with a lower critical level can block the complete system, so that we don't have enough throughput for the real-time transmission, for SCADA commands and so on. Okay, so I think also the transmission system itself, okay, time-triggered systems also, so that the communication system itself will be controlled, who will get the resource of the transmission to which application and to which security level and safety level of applications. That will be important as well.
Right, so you brought in the transmission system. So basically, I think it's very reasonable to put this also into the focus. But then we see we have a really, really complex system with a lot of, well, of course it's a systems of system, and with a lot of areas with very different criticality levels. And you have mentioned the other domains from which we can actually learn, like trains, planes, and other areas. How did they cope with this? I mean, these are maybe of similar size. Is there something like a fragmentation of the solution space, or how did they cope with this complexity issue?
I cannot be 100% sure. I can just give my opinion. My view is that everything is being driven by liability. That's why I believe that the whole cybersecurity issue is a process. It's not just a set of technologies that you choose from. And over there, the liability is very clear because it affects you know, every single person who participates, a driver, for example, or a passenger, or whatever. Not that, let's say, blackout does not influence the well-being of people, but I don't know any company that had a blackout and was asked to pay liability damages to any of its customers,
Yeah.
at least up to now. However, for cars, I hear it all the time. So I think that that's what is really driving their technology development, so that they can claim that their systems provide specific properties. And that's what has brought them, I believe, a little bit further than the rest of the other fields at this moment.
Yeah.
But the technologies that are using are technologies that can be used also in other domains, like in power grids and so on, and can be exploited. Like, for example, the use of formal methods and related tools to develop safe and secure software for processes, for SCADA, for example, or PLCs.
Yeah, absolutely. Yeah. Yes, please.
Maybe I'm throwing a bit of oil in the fire now. But exactly in, let's say, in the automotive area, until now it was exactly like this, as you say. But now that the vehicle is becoming, let's say, more and more autonomous and more services are entering, let's say, the vehicle, and more different stakeholders like only service providers from the vehicle. There are also there's a lot of discussion there how the liability will be treated, and this is something that is, let's say, it's the same also here in the power grids.
Yeah, well, for sure we'll have this discussion. Yeah.
Yeah.
Especially as you say that
The more
basically hierarchy is
stakeholders
disappearing. You have
complex
more
it gets,
stakeholders. Exactly. Yeah. So, are there any comments or questions from the audience at this point, taking into consideration the general question of state of the field? Where should we put a focus, and what can we learn from other domains? Is there any comment so far? Daring comments you want to say? No. Well. No, right. Okay, then let's maybe come to another. Oh, there is one. Oh, sorry. Yeah, Paul, for sure.
Maybe it was just more of a very directed question from Christoph's talk. So I like this idea that we need to focus on these critical transactions in a bottom-up sort of way. So I guess my question is how readily can we identify these critical transactions in these very complex systems that we're developing? There may be some transactions that maybe when a system's in a certain state don't appear very critical, but maybe when it's in a certain other state is very critical. I mean, so do we have the right sort of tools or analytical methods to identify what are these transactions and what are the states, or what are the data values that could push us into these critical states, and therefore allow us to see which are the ADPUs that we should be protecting? Is that something we understand at this stage, or is there still open research there, do you think?
There's one there, but I can have this as well. The question was basically, do we have the right tools to deal, Paul, help me, with
How are we able to identify these critical transactions? Some transactions.
Oh, I think in the case for smart grid security, it's a lot of work, but not too difficult, because we have the standard 61850, and there you have a complete list of all commands, of all parameters, of all settings. So we have to go through this standard. It's 15 parts or so, and say, okay, how critical is which parameter, and how there are parameters interrelated also. Okay, to change one parameter, what are the consequences to other parameters? I think we need a lot of effort to put here to analyze the data models and the parts of this protocol. Yeah? And even in Industry 4.0, there's an OPC UA standards. There it will be a little bit more difficult because they are very generic. In 61850, you have a concrete list of items. Yeah? Not so generic. But of course, when you do it generic, it's more difficult.
Right, thanks. Yeah, I think it's really distinguishing between the criticality levels, either in communication, what do we really have to protect, what is not so important, but also in system design is, I think, one of the things which is very domain specific. So here we can take over concept from other areas, but we have to really see how that fits to that system. And I found this idea of cyber-physical systems versus non-cyber-physical systems quite important point. So most of the security systems or approaches we are using today are coming from the non-cyber-physical area. Maybe that's already a bit old-fashioned. There's lots of stuff has happened in the recent years, but still we have to be careful and see how that really applies to current systems, right? Okay, so now, as we said, on my question, where the focus is, you, for example, mentioned that we should actually, different players in the field should follow different tasks. Like you mentioned, industry should put really the attention of that something has to be done, and what is actually the level to achieve. And the question is, so where should we actually raise the attention? What bodies should we address, and in which way? Maybe we can reflect briefly on this, and yeah, okay. Maybe you can start.
Okay, so the question is where we should raise attention.
Yeah, whom to address? Is it regulators? Is it industry? Is it consumer organizations? Probably not just a single point, but what strategy would you suggest, or what?
I mean, of
crosses
course, it's
your mind?
Everyone.
Yeah, for sure. Yeah,
it's the easy question. I think such let's say very measures that apply to the entire society are, let's say, more easily applied from the top. Mm-hmm. We can see, for example, the example of the NIS that this comes from the EC, and then suddenly everyone is running
chasing
behind it.
Yeah, yeah.
Of course, yeah. I mean, we cannot wait because the top is let's say a projection of what the bottom is, and so for that, I think in general, cybersecurity should be a topic in every thing. I'm not sure where we could, let's say, start focusing.
All right, yeah. Yeah. But you mentioned
probably
the NIS directive. Yeah. So, for example, regarding that, the European Commission awareness on this topic is there, mm-hmm. But is the NIS directive now enough, or where do we see, you see any gaps in there still? So, for example, I know in Austria it's mostly discussed in the context of missing the right vocabulary now in English, the attention on if a cyber attack has happened, then this is actually recorded. Incident management, yeah. Thank you. Yeah. And the other points, which I just learned through the presentation today, basically are not mentioned at all. So, do you see any gaps there? Is there something we should raise the attention to? Also a question to the audience.
Let's say probably, I mean, if the NIS is only for incident, then it creates a bit of, let's say, presence of the subject. But of course, the research and let's say the security professionals should show, and for example, tools as we saw in the demonstration are very good for that, to show what is, let's say, the direct impact of let's say attacks, because it's very often that you have the research and they talk about a problem that is real, but it's being described very abstractly, so no one can let's say directly connect to it. And then you have the industry where all comes down to, let's say, money, so, and the cost. So there somehow you have to do the connection and bring it.
So Professor Serpanos, you said it's a process all the time. So how far is reality ahead of our research?
Oh, out of research. Well, it depends on what you mean reality now.
Well, or the
you are
state and the
referring
field,
to-
let's say. Yeah.
If it's the reality in the eastern part of Europe and
Yeah.
further, then that's a very strong reality.
All right. Yeah, yeah, for sure.
If we are talking about consumers, it's very different. So, well, I really believe that it's, as I mentioned, that it's a process. Awareness is important at all levels. I think that depending on the application domain, things may be different. So, for example, with critical infrastructures, it's more important that the operators, as well as governance, management of the critical infrastructure and cybersecurity, be efficient and controlled, for example, in one or very few places. In other domains, it's more important to bring awareness to consumers because of their actions. So, for example, just to bring a different example, if people are using mobile phones, they should be aware of the dangers that mobile phones have. They are not the same for their smart meters, for example, so awareness is much more important in one domain rather than another, but it should be everywhere. And in regard to legal aspects and management, because I consider the Commission as also part of the chain of management. I think that we have a long way to go because even this directive does not address everything in terms of governance and management and bringing everybody together at the European level to have a unified methodology and framework for facing all these challenges for cybersecurity.
Okay. I think we need also some activities on the legal and regulatory level because all of us, we depend on the software which is downloaded and the software which is installed. And this software is not certified. Nobody has controlled it, what is inside. And the damages which can be caused can be huge. For example, take the smart meters. In the smart meter, you have one regulated part, which is controlled. Everything what has to do with metering has to be checked by some governmental organization that really that the metering data which come out are 100% true and cannot be faked and manipulated. And the other part of the software in the meter is not regulated. That is done by the manufacturer, and that he can implement what he wants. That's its own. That's not does not consider the metering data, but it concerns the operational data and the operational behavior. And today we know the damage which can be caused by bad operational behavior can be much higher than wrong metering data. Okay, of course there may be some loss of money also, but it can be detected. But the system security and the system safety is much more depending on the uncontrolled software. And I think here it is necessary that something happened also in this area, that not all of the software or the risky software can be uncontrolled, loaded and patched and so on, and nobody knows and which software is running. I think like in the future for the cars, the software has to be accepted by one governmental organization, and the hash value is calculated and the hash value is restored, and at each time it is possible to verify which version of the software is loaded and if it is still correct. I think too much depends on this software which is developed internally by any manufacturer.
All right, yeah. So, any more comment? No. I think if there is no comment from the audience at the moment, I try to conclude the discussion now. And basically, we have seen in the last 2 days that we are, I think, still exploring the space. I think this is a necessary exercise we are doing now. And we discussed that after the demonstration in the lab, actually, we then should do the step and try to to go a step back again and try to generalize the very specific outcomes we are currently doing in our research activities. And I think the light is shed on the area of security in power systems, because I think the attention is there. It's a very critical issue. And also the sign that this NIS directive we were discussing, is the first European directive on security and it has been done in the area of power systems. I think this is a very clear indicator for that. And I think the learning process has to go on, and as you say, it's an ongoing process, so we will be busy for some time with that. So thanks everyone for coming. Thank you for discussing with me. And have a safe trip home. Thanks a lot.